Hi folks, we're going to take a look at number 9 from page 241. So they're asking us to prove this identity. So even before I start, I notice here that this looks a lot like the cosine 2x identity. It looks like the expressions are just switched around. But I don't want to put anything in terms of 2x because I look at the right-hand side and I see everything's in terms of x. So I'm actually going to start with the right-hand side because that looks to be a little bit more complex. All right, so here, again, I notice cosine. Here I've got tan and cotangent. So one trick that's often useful, especially since I have this sine and cosine outside of the brackets, is just to turn tan and cotangent in terms of sine and cosine. So that's going to be my starting point for those reasons. Okay, so here we've got tangent, which is sine x over cos x, and this is cos x over sine x. All right, so the first thing I'm going to do is going to subtract this, turn it into one single fraction. Okay, so again, these things on the outside, I won't worry about them yet. So here the common denominator will just be cos x sine x. All right, so for this first fraction, I need to multiply the denominator by sine x. So I'm going to multiply the numerator by sine x. So that's going to give me sine squared x. And similarly here, I need to multiply the denominator by cos x. So I'm going to do the same thing to the numerator. So minus cos squared x. All right, and I see something very nice because these factors of sine x and cos x in the numerator reduce with the factors of sine x and cos x in the denominator. All right, so now I'm left with sine squared x minus cos squared x. Before I do anything else, I'm going to take a look at that left-hand side. And I think this is where now I see something else that looks a lot like the cos 2x formula. All right, and again, these expressions are interchanged. Okay, cos 2x is equal to cos squared minus sine squared, and it's also equal to 2 cos squared x minus 1. So I think the best thing to do here is to factor out a negative 1. All right, so this negative cos squared will now become positive cos squared, and this plus sine squared x will be minus sine squared x. And of course, this in the bracket is just equal to cosine of 2x, and of course cosine of 2x can also be written as 2 cos squared x minus 1, and now I apply the negative to both, and that's going to become positive 1 minus 2 cos squared x, and there's my left-hand side. All right, so I've proven the identity. So I would even say you could almost go from this line directly to this line here. All right, since we know that these two things are equivalent to each other. But if you want to put that extra step just to be sure, that's perfectly fine. So just to recap, I started with the right-hand side because it seemed to be more complex. Okay, good trick that we often use, especially if there's sines and cosines elsewhere on that side or the other side, is to turn anything in tangent, cotangent, secant, cosecant in terms of sine and cosine. And then from there, I just followed the algebra along and noticed that this expression here, like the one on the other side of the equation, looked a lot like the cos 2x formula. All right, that's it for this one.